Baxter. Good job. Way to have your goggles on. You're going to start security here in just a minute. The show's about to begin in 5, 4, 3, 2, 1. Begin security. Hello, boys and girls, my fellow scientists, and welcome to Mr. Patrick's Laboratory. Man, we have an exciting show planned for today. This is the second episode of the same topic. We're going to be talking about pressure today. It's going to be a great time together. Now, it's very important that, that's the sound. It's very important for today's episode that you make sure you wear your goggles, your eye protection, something to be careful, because there are things that can get in your eyes today, and so we're going to have to be very careful. Now, before we begin, I need to have a quick discussion with you because I'm going to do some really cool stuff today. And parents, this is the disclaimer I want to make sure that everybody has for families. In today's episode, we're going to be using something a little bit different than we have in any of the others. We're going to be using fire for part of it. Now, kids, you need to listen very carefully, and I'm very serious here for a minute. You need to make sure that if you are going to be a part of this, that somebody that's an adult is helping you. If you have a brother or sister or somebody that's over 18, they can help you. You cannot do this by yourself, okay? You have to have an adult that helps you. Why? Because I don't want you to be hurt. Okay, I don't want you to be hurt. Fire is dangerous. We never play with fire. Fire can not only hurt you, it can hurt others. Fire can catch houses on fire, and I don't want to do that. But we're going to do something fun. Now, you need to understand, I'm a high school chemistry teacher, and here's how we do it in my class. If you're going to be in the lab and we're going to do the cool stuff and the fun stuff, you have to wear goggles, and you have to listen to the safety. So I just did both. We did goggles, Baxter's got his on, we're ready to go. And we talked about safety. When we get to the things that are about fire, you've got to be very, very careful. Now, kids, I need you to help me a little bit. If you catch somebody that's helping you, your mom, your dad, your aunt, your uncle, y'all are doing it together, and they're not wearing their goggles, make sure and remind them. You need to have eye protection. Please be careful. Now, here we go. We're ready to have a great time. We were talking about in the last video, if you missed the last video, you missed some of the coolest things that go with this video. So you need to make sure that you go back and watch that. We're talking about pressure. Now, in this balloon, we have pressure. How did I get the pressure in there? Yeah, I blew air into it. Now, when I blow air into it, the container, we call the container a balloon, that container gets bigger, and we can get it to do work. Now, before we go too far, one of the demos that I have today that you can do at home takes a little bit, so we're going to do that one first. Wait just a second, let me get my stuff. Here's what we're going to do. You're going to need a bottle, water bottle. I have a funnel to help me. We're going to have some sugar. I just have a sugar container. And I have a package of yeast, okay? Yeast, I'm going to talk about that stuff here for a minute, but let me get it started so we can understand. Now, I have to have warm water. So I'm going to go ahead and turn the sink on for a second so I can get some warm water. Now, yeast is a microorganism. It's living, but it's dried out, okay? Now, yeast is used in a lot of different things. You're going to end up using yeast in breads. Oh, I love bread. Cakes. I love cakes. Cupcakes, bagels, pizzas. Oh. Miss Christy, maybe we should stop the video and eat first. This is making me hungry. No, we'll do it after. But we're going to use yeast today. Now, I'm going to need a little bit of warm water. It's not quite there yet. It will be here in a second. But here's what you need to know about yeast. What we're going to do is we're going to take yeast and we're going to put it inside of this water bottle. So I'm going to take the whole packet, and I'm just using a funnel so I don't get it everywhere. Okay? It's the only reason I'm using a funnel. I don't want to get it everywhere. Get it down in there. Okay? Now I'm going to need a little bit of warm water. Here it comes. Let's turn that down a little bit. Yeast are dried out. Okay? Now, the thing is, I'll shake it around just a little bit. Shake that up just a little bit. But I have to give them some food. And yeast needs sugar. And so what I'm going to do is I'm going to take this container and we're going to have some sugar. Now, how much sugar do they need? Well, I don't need to give them too much because they might get fat. Okay? So what I'm going to do is I'm going to take a teaspoon, just a little bit more than a teaspoon of sugar. Okay? So I'm going to make sure that all goes off in there. So I've got my yeast, I've got them in water, and I've got sugar with them. So I gave them food. Now, what's going to happen with them is that they're going to do what you and I do. Okay? Mix it around really good so I get that sugar dissolved in there so those yeast are floating around. Now, they're single-celled organisms, which means they're really just Tiny, 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 tiny. Now what I'm going to do is I'm going to do something a little different. I'm going to grab a balloon, and what I'm going to do is I'm going to write something on here. If I can, it's deflated. Come on, marker. I'll write the word science. That looks horrible, but it's hard to write on a balloon. And here's what we're going to do. We're going to take that balloon, and we're going to put it over the edge of that bottle. That's all you do, but it takes a little bit to happen. So what do I have inside? Make sure everybody understands. I have a single-celled organism called yeast, and it's got food in it. Where did it get its food? Sugar. And so I give it some sugar, and it's in some water. Now, the warm water helps it speed up the process. So what I'm going to do is I'm going to let it do what it does, and I'm just going to put it over here by itself for a while. So that one takes a little bit, okay? That one takes a little bit to happen. Now, let me tell you about yeast for a minute. All those things that I called out, breads and cakes and cupcakes and bagels and pizza and all that, all those things that have those bread type things, when you go to cook them, now some of you cook and that's awesome, but as you cook, what's going to happen is they rise. And so what's going to happen is that yeast is going to make a gas. And we're going to talk about that a little bit, but that's why when you eat a roll at a restaurant, or your mom or your grandma makes really good food and you eat it, it's so light in the middle, it's because it rises over time. And so we're going to have that's a chemical reaction, and it takes a little bit to go. And so I wanted that one to take off. And so let's talk about what we did last time, and then we're going to move into the rest of them. I knocked one of them off the table, okay? And so we were talking about this balloon, and we were talking about how we have pressure. There's pressure on us all the time, pushing on us. Now, we build pressure by doing some different things. One of the things that we did in the last video is we had this one. Now, this is that Cartesian diver. Now, this is from school, and this is one you probably can't do at home, but it's a 2-liter bottle, has a test tube in it with a piece of balloon on the bottom. And remember, here's what happens from the last video. As I squeeze it, I build pressure on that liquid, and it sinks. Okay? And I squeeze it, and it sinks. I use pressure to do work. And in the last video, we talked about this is how those big earth movers pick up dirt, and they dump it different places. They put a pressure on a liquid called hydraulic fluid, and they get it to do work for them. So we can use pressure. That's pressure on a liquid. Okay? And then we did this really cool one. This is one of my favorite ones. It looks like I just pulled a can out of the recycle bin, but that's not what I did. You need to make sure, if you didn't see the last video, you go watch this. But we smashed that can. We smashed that can in the last video. But how do we do that? We didn't use water pressure. We used air pressure. The pressure that's around us all the time. And here's what's interesting about that is when air pressure pushes on me, I don't get crumpled up. Why? I have bones inside. I have bones inside that push out and fight against that all the time. But that can doesn't have that. And when the air pressure changed, it just smashed it. So make sure you check that one out. And then last but not least, what we did was we made a foot rocket for some of these darts that you see on some of the games that you buy. And we took a bottle and we put a pin in it. That's all it is. I took the ends off both ends of the pin, made a little tiny hole. Hey, I got a little help for you, because when I shot it in the video, the pin kept coming out. I had a good idea after the video went off, and here it is. After you get that in there, take some hot glue, put some hot glue or some super glue around that hole to block it off and keep it in place. And when you stomp on it, it shoots that rocket. And so you can do target practice. Hey, by the way, if you did any of those with me in the last video, put those down in the bottom. I love seeing the pictures of people doing things. People leaving comments. I'd love to see what you did. What can did you do? Oh, by the way, these aren't the biggest aluminum cans I've ever seen. Wonder if you could do it with a bigger can. I don't know. Check it out. Get pictures of it. Send it to me. Put it down there. Okay? Let your mom and dad do it. You notice I did 2 that day. Why? Because I like it a lot. And so I smashed 2 of them. And maybe your mom and dad or your family can do it. And so you can have a great time. Now, I want to remind you about one other thing. I had another bottle, and I don't have it here. We had a balloon inside, and we were blowing on it. We talked about being careful that if you blow on that balloon, you need to make sure that if somebody else is going to use it, they use another balloon. Or you clean it off with some kind of cleaner. Okay, you're going to use some swab, or you're going to use some hand sanitizer to clean it really good, let it dry really good, and then somebody else. We don't want to spread any germs. We've talked about germs. Germs everywhere. I just don't want the bad ones around me. But today we're going to do some other things with pressure that are incredible. Now again, we have the first one going over there. We're going to see what that one does for us. But we're going to do something a little bit different here. And Miss Christie's going to have to get a little closer for this one. And here's what I have. I have something that probably most of you have in your house. It's a marshmallow. Now, if you're going to use this one, if you're going to do a marshmallow, you need to make sure that it's a fresh one. Okay? Now, a marshmallow is really, really interesting. It's a sugary substance that has air puffed through it. Okay? It's pushed through this liquid and it puffs up. Okay? And so, that was good. Okay, and so this marshmallow is really cool. So what we're going to do is we're going to use pressure to change it. Now, what I'm going to do is I'm going to use a syringe. Now, at your house, many of you will probably have one of these. This is what little kids, sometimes mom and dad, when you were a little kid, this is how they had to give you liquid medicine. So they would suck up medicine in it, and then they would put it in your mouth with that. Maybe you have a puppy dog that has to have medicine. And so that puppy dog has medicine, and so you use a syringe like this. Now I'm going to show you in a big syringe that I had from school, and then it's really actually cooler in this one, but I want you to be able to see what's happening. So I'm going to take the plunger out. Whoa! That almost scared me. And so I'm going to put a marshmallow inside. Now, here's the big thing you need to know. We're going to use this plunger to move in and out. But the most important thing you need to know is you do not want to smash that marshmallow into the end. You will ruin your syringe. And so here's what we're going to do. I'm going to put it close. See how close it is, but it's not smashing. Okay, just like that. And here's what we're going to do. I'm going to put my thumb on it. And what I'm going to do is I'm going to pull out. Now, this is very important. I got to use a little bit of pressure. I'm like really hold my thumb on there. See my finger changing colors as I do that? I'm going to really do that. Now watch what happens when I pull on it. It's getting bigger. Can you see that? Oh, did you see that happen? Okay, I'm going to do that again. Ready? Pull. Is that how they make the bigger marshmallows? I don't think so. What they do is they use more of that sugary substance and add more air. Now, if I can, I'm going to do it one more time. If I'm going to put it in there and I'm going to pull pressure, boy, look at it get bigger. Now, I need to explain what's happening. Okay, so pressure can go in and pressure can come out. And so what I did with that marshmallow is I had it in there. When I pulled that pressure, is normal pressure pushing on it anymore? No, and it can spread out and it looks like it's getting bigger. Now, if I can pull the pressure away, like a vacuum cleaner, it pulls pressure. That's how you get dirt off your carpet or off your floor. Then I should be able to do the opposite. So Miss Christie, I'm going to use another. Stay down there. Okay, I'm going to use another one, but this time I'm going to add pressure. Now, this one's important to catch what I'm doing. Okay, I'll take it where the numbers aren't there. I'm going to put the plunger way at the end, and then I'll put my thumb on it, and I'm going to push air. Now, it's full of air inside. Now, I put my thumb on it to make it close. Watch what happens when I smash it. Watch that marshmallow. Oh, look at me smashing it. Now watch this. As I let it come back, it goes back. Here it goes again. Smash it down. And then it gets bigger. Now watch this. Listen. Did you hear the pressure change? So it's building pressure inside. So what is happening is when I have the plunger way down there, have my thumb on it, as I'm pushing on it, it's trying to get out. All I can do is push on that marshmallow, and I'm getting it to do work. Again, I don't want to ruin this syringe by letting it smash it to the end. Now, here is the little one that would be in your house. Here's how this one works. This is why I think it's cooler, but I wanted you to see what I was doing in the big one so you could do it in your small one. Now, all you're going to do is the same thing. I'm going to put it down there. Don't smash it in the end. It's close. I'll put my thumb on there and watch the marshmallow grow. Oh my gosh. Did you see that? Let's do that again. Oh, and it's filling up that space. You can really see how much growing. One more time. Man, this one's fun. I'm going to tell you, my high school students love it when we do this one. Okay, I'm going to pull that one out, but use a fresh one just so I can smash it around. Okay, and here's what I'm going to do this time. I'm going to have the plunger down here on the end. Okay, so it's way down here at the end. Got my thumb on it, always holding it tight. Here we go. I'm going to smash it. Look at that. Oh, yeah. Okay, did you see it get bigger when I let my thumb off? Let me do that again. Here it comes. You can see it smash. You can hear the pressure come off. And so you want to, this is really, really, really cool. Now, you may think, why did you keep switching marshmallows? This is important. If I move air in and out and in and out and in and out of it, does it stay fresh anymore? It doesn't. It's just like a balloon. If you blow it up over and over and over and over, what's going to happen eventually? It's going to pop. Why? You wore it out. So you can wear out that marshmallow. Now, people ask me, Can I eat them? Well, here's the deal. I always go with this philosophy. No. And what I'm going to do is I'm going to go back to the bag and I'm going to eat other ones that haven't been in here. And this is important. If it had medicine in it one time and then I put a marshmallow in it, I don't think I want that medicine in my mouth. If I use the really big one, whatever it was used in my chemistry class or somebody else's class, I don't know what was in there. So you throw those marshmallows away, you eat the ones out of the bag. Wasn't that one cool? That one's really, really cool, okay? So we're going to go to the next one. And this one's going to be really sort of different, okay? In this one, what we're going to have is a jar, okay? We're going to have a jar, and we're going to have a water balloon. So I put some water in this water balloon, okay? Now, so let's talk about this for a second. If I'm doing air and I blow it up and blow it up and blow it up over and over and over, it can burst. Same thing with a water balloon. When I go to air it up, okay, I would put water in it, it can actually explode. And I really don't want it to explode. So what I'm going to do is I'm going to put water in it and just check it real quick. All right, you want to notice, adults, this is a great one for preschoolers, okay? Again, just a reminder for everyone, I'm not making up these. Okay, I'm going to step away from my experiment. I'm sweating a little bit. Woo! My goggles are getting wet. That's what you do. You step away, get yourself ready, and you come back. That's what I do with my high school chemistry kids. Okay, this is a great one for elementary preschool kids. Now, again, I don't make up these videos, okay, or I don't make up these experiments. I am using ones that you can look up anywhere. I'm just showing you how to do it so you know how to do it, okay? So I'm just being a demonstrator of what's going on. Okay, so this one's fun with little kids, and you can give it to a really little kid and say, I want you to take this water balloon. Be very careful. Now, little hint, don't use the regular water balloons that you throw for activities and stuff. I used a normal balloon, a big balloon like I had over there. By the way, real quick, check out my balloon. Check out what my balloon over there that says science on it. See what it's doing? We'll come back to that one in a second, but I want you to see what's going on. That's really crazy looking. You can see I wrote science on it, okay? I wrote science on it, okay? And it's something's happening. And the reason I show you that is right as it happened, I wanted to show you, but it takes too long. And so we're going to come back to this one. But what's going to happen is I don't want to use a regular water balloon. I want to use a full-size balloon that I put water in it. Hand it to a small child and say, I want you to put it inside. Now, here's what happens. As I push on it, and I'm not pushing real hard, a water balloon would burst. That's why I don't want to use that here. But as I'm pushing on this balloon, it doesn't fit, right? You can tell. Now, for a little kid, a little bitty boy or girl, they may not figure out what to do. But we're going to do something different. Now, this is where you got to really pay attention. I've already given the warning. This is where I'm going to use fire, but I want you to watch. This is incredible how this works. Okay? So what we're going to do is we're going to set that balloon there. This is where you have an adult. Okay? Kids, this is not for you. This is for an adult. You're in charge of the balloon. So if I'm the student or I'm under 18, I'm holding the balloon ready to go. You're going to see what I'm going to do, and you get to do it. So here's what happens. Stay, balloon. Stay. Thank you very much. And so what, parent, you're going to do is I just have a piece of paper, okay, and I have a lighter. So all the things I need for this is a jar of some sort that has a balloon that doesn't fit in it. So I made sure it's the right size for my kids so they can do this. And so here's what that parent's going to do. You're going to take and you're going to light the paper on fire. Now watch what happens, kids. I'm going to drop it inside like that. Then I'm going to put the balloon on it. Watch carefully. Watch carefully. Oh! Wasn't that crazy? How did that happen? How did that happen? It didn't fit. I was pushing on it. How did that happen? Well, this is really, really cool. What happens is there's a change of pressure. Now you may think, well, why did you use fire? Well, let's think about this for a second. Fire needs oxygen. And so when your parent or the adult lights it on fire and drops it into the jar, what happens is it's burning. But as soon as I put that balloon on top, I stopped air getting in. And so that fire wants to keep burning. And so it can't keep burning. And so when it uses up all the oxygen, we have a change in pressure. Hey, remember the syringe? Instead of using this, I used the fire to take out air. It used up the oxygen. And all of a sudden, did you see the balloon start jumping? And then it sucked it inside. It was a change in pressure. Now, for my older kids, 4th, 5th, 6th, 7th, 8th grade or older, where was the greatest pressure? Was the greatest pressure inside the jar or outside the jar to make it go inside? Now that may be confusing, but let's think about it this way. When I had it on top, how could I get it in if I really want to? I'd shove on the top. So where's the greatest pressure? Here. And so what happens is, how did I get it to go in? I made less pressure with the fire inside, so it changed the air pressure inside. So normal air pressure that's pushing on everything, pushed it inside. And you may think, how do you get it out? Well, it depends on how big you made the balloon. I'm going to try. I haven't seen. And so let's try this and let's see what happens. And so I want to use a little water to get all those little pieces out. Okay, if I shake that balloon around a little bit. Oh. Okay. It might break. Oh. It might not come out. You know what that means? It means I'm just going to have to break the balloon and I'd have to get another one to do it. That's how I knew it didn't fit in the first time. So check it out. Stuck. That's what happens. All right. Now, I'm going to do this same experiment on a different level. If you remember to the last video, we used a pressure cooker. Remember, Flat John told us, make sure you cough into your elbow. Ah, you know that. You've been watching these. So what I'm going to do is something a little bit different. Okay? In that pressure cooker, we had an egg. Now, I'm going to wash my hands really good. I'm going to get that paper off my hands that was burned up. And so I'm going to do something a little different. And you got to watch really carefully how I'm going to do this. Okay? Here's what I have for this demonstration. It's going to be similar, except it's crazier. Okay? And so here's what's going to happen. In that last video, we boiled an egg. We cooked something in a pressure cooker. And we talked about how it builds pressure on the inside. And when it builds pressure on the inside, you can use it to cook. Pressure cookers are used all the time for people to cook. Ask your mom or dad. Ask your grandma. Do they have one? Learn how to cook with one. It was really cool. We boiled an egg. We made a hard-boiled egg in about 5 minutes of cooking time. It was pretty fast. Why? Pressure and heat can do work. Okay? And so what we're going to do in this one is this. I found a jar. This is just a juice jar. And so you'll have to check it out. Now, I'm going to show you with a raw egg real quick so you know how I picked it. Found a jar. My kids drink juice. And so I had to find one that had a neck like this. Now I want to show you the difference between these two. Okay? This first bottle had a really big neck on it. That one had a really big neck on it. I don't want that for this one. Okay? This is one that I tried out like this. The egg should sit like that. Okay? It should sit like that and you'll know this is the egg you want to use and the jar you want to use. And so what you're going to do is hard boil that egg. I've already done that, so I'm going to put this one back away so that it stays for breakfast tomorrow morning. And then what I'm going to do is something really different. Now, it's very important that you catch this. This is my second experiment with fire. And I'm real serious when I say this. I don't want any of my friends hurt. And so you have to have an adult help you with this. Okay? You got to have an adult help you with this. Okay? So I have my jar. I have my boiled egg. Now, what I'm going to do is something a little bit different. I'm going to use what is called isopropyl alcohol. Moms and dads know what isopropyl alcohol is. That's why you want to have an adult that helps you. Okay? You want to have an adult that helps you with this completely because you want to be safe. Okay? So using isopropyl alcohol, and I have a pair of tongs. Okay? So what we're going to do here is going to look very similar. Now, in the last one, I took a piece of paper as the adult and I dropped it in there and I had a young child set it on it and suck it in there. So this time we're going to do something a little bit different. I'm going to take that cotton ball that had isopropyl alcohol on it, and here's what we're going to do. Again, an adult does this. See it catch on fire? Now watch this. I put the egg on it. Watch it jump. Come on! And the egg sucked inside. Now you may think, that was really cool. And you know what? This is the first way I ever learned how to do this. Suck an egg into a bottle. And Miss Christie, you want to stay about right there for the next part. The reason I do this one is because I think I can get it out. And I'm going to show you how. Now, you have to listen to the science behind it. Okay? You have to listen to the science, and here's how it works. How did I get the egg to go inside? With the fire, I dropped pressure inside. Pressure pushes it in. So how do you think I could possibly get the egg out? I'll give you a hint. You can. How do you get it out? Well, if pressure pushed it like this to go in, how do I get it out? You do the opposite. You have pressure on the inside that pushes it out. So I'm going to show you how to do this. Now this part's super important, so make sure you watch. I'm going to take and get that cotton ball out of there. That's super important. There's that cotton ball, okay? I'm gonna wash the jar out really good, okay? Really, really good. I'm gonna wash it out a couple of times. Now, this is for an adult to do, okay? You should be over the age of 15 to do this. Over the age of 15, okay, to do this one. If your parents are with you, then maybe they'll give you permission to do this, okay? I want you to watch what's about to happen. I want to dry it off so you can see the egg in there. Can you see it all right, Miss Christie?
Yep.
All right. And so here's what we're going to do. Make sure there's no water. Okay, watch what happens. That egg's inside. See that? Now, an egg has a rounder side and a pointy side. So what I want to do is I want to take the egg and I want the pointy side to be down. Just like that. Okay? Now, from what we learned a while ago, pressure was bigger out here and shoved it in. So to get it out, I want greater pressure inside. Now, how do I get pressure in a balloon? You blow in it. So that's what I'm going to do. Now, if I blow on this, first of all, I'm not going to suck on that egg. Ooh, I'm just going to blow on the jar. But when I blow on it, is the jar going to get bigger? Nope. When I blow on a balloon, it gets bigger. Why? Because the container can expand. For my older kids, why? This is a solid. That latex that makes that balloon, or the material that makes that balloon, is not. It will flex. This won't. So what I'm going to do is I'm going to put my mouth on here and I'm going to blow on it. As soon as I can't blow anymore, when I take my mouth off, it'll pop out and I should be able to catch it. All right. Ready, Miss Christie? Here we go. And there it is. It's that simple. Now, it looked like, oh my gosh, she sucked on it. No, I didn't even taste it. Why? Because I washed it off after I did that. So one more time, how did I do that? I found an egg, I boiled it, I made sure it would fit, okay, and I boiled it, hard boiled it, took the shell off, okay, it's soft. And then I had an adult take a cotton ball, isopropyl alcohol, light it, drop it in there, saw it go in there. Now, all I had to do, pressure was greater out here, pushed it in. How do you get it out? Get greater pressure on the inside and it pops out. Did you see me catch it? I used to play baseball. I had a big time. And so that's how you make that work. Why? Pressure. Now, make sure that you're being safe. Make sure that you're being safe. Now, for my last experiment, it sat here the whole time. I'm going to bring it over here. Check out what's happening. Check out what's happening. But I want you to look, Miss Christie, make sure you show the inside of the bottle really good. That yeast is reacting. Remember what its food was? Sugar. And so it's got sugar in there to help that yeast. And that sugar is what it's eating off that sugar. And so what's happening is it's all down in there and it's making a gas. See, this is all foamy. And so what's happening is it's making carbon dioxide gas. And that gas is airing up my balloon that says, well, I tried to write science on it, but you can see it says science. And so you know it's the same balloon that I had from before. The longer you have it, oh, I know what somebody's asking. Will it make the balloon get really, really, really big until it explodes? No. And here's why. That bacteria will eat up all the sugar that it can, and then it'll stop. Okay? So here's a good example. When they make bread with yeast, does the bread in the oven get bigger and bigger and go all over everything, and you eat the bread that they pull off the side of the oven? No. It's going to make that carbon dioxide, and that carbon dioxide is rising up there, and it's making this balloon. See, so watch. Oh, man. It is really pretty good, and it's really, I'll turn it sideways so you can see how it's bulging out the side. See that? So it's producing a gas. We can build pressure. So real quick for you, we can have pressures on liquids. We can make pressure with gases. We learned how to make it do work for us. How we got it to take a water balloon and suck it into a jar. And then we found out how to take an egg and suck it into the bottle, and then how to get it out. Okay? You would not want to try that. You would not want to try that with this one. This is a quick one. You would not want to try it with this one. Your mouth doesn't go over the end of it. Plus a water balloon can hurt you, so you don't want to do that. That's why I did it with the egg. One last thing for you. Hope you had a great time. We've done it in a whole lot of different ways, and we're doing it safe all the time. And so I got something for you real quick. I'm going to get really, really close. I wore a special shirt today. All right? Make sure you can see it. See the smiley face on it? And it says, humankind, be both. Humankind, be both. I can do that. You can do that. Kids, you're my hero. Let's have a great time doing science together. Have your mom and dad ready to do some fun stuff. Remember, because it's about science, science at Mr. Patrick's Laboratory. Have a great time. We'll see you in our next episode.